So like I mentioned, today we will review chapter 5 and chapter 6. And let's say again, we don't know, let's say that this is your question on your test that we have in tomorrow. And how do you determine, and again, your question is not really this structure, is basically your question probably just A and B, and then C and D will be another question. But again, the reason why I put it on this slide is to show you, or to hopefully you guys can identify that A and B are different from C and D, right? So let's take a look at this item. They give you, suppose that there is that in a bowling league, a score among all bowlers are normally distributed with the mean mu equal to 182 and the standard deviation of 14 points. Find the following, right? Find the proportion of the population who score more than 195. Find the probability that a random selected person who score less than 150. Suppose that a sample of 100 bowler is selected. What is the probability of the sample mean score greater than 195? And based on 100 bowler from part C, find the probability of the sample mean between 175 and 185. So looking at this thing here, we know that they asked us for the probability of more than, probability of less than, probability in between. So let me, looking at this thing here, the one thing that you should identify, or the one thing that you should spot out the difference between A, B versus C is in C, they give you a sample, right? In C, they give you a sample, and in C, they ask you for probability of the sample mean. So whenever we deal with a sample, right? Whenever we do a sample, that's when we in 6.2, or that is when we have to find our standard error. We need to adjust our standard deviation and using the new standard deviation, or in terms standard error. Okay, so before we do that, let's take a look at A. So in A, there is that we are dealing with the population, and if we deal with the population, whatever they give us, which is the mean and the standard deviation, that is what we're going to use. So they ask us for the population or proportion of the population more than. So again, as always, we want to sketch our standard normal curve, right? Our normal bell-shaped curve. And looking at this thing here, we know that we're looking for more than, meaning anything to the right of 195 will be more than 195. So we shade this region to the right, meaning we're looking for the area underneath the curve of that, right? We're looking for the area under the curve to the right of 195. And if we have this reminder again, all we're using is a normal CDF. And again, our normal CDF, we need the lower limit. In this case, our lower limit is 195. The upper limit is some humongous number, because it's keep on going to the right, some humongous positive number. And our mean will be 182, and my standard deviation is 14. So if I type that in, if I type those in, this is what I have. And again, you will have 0.1766. And depend on your test will tell you 3 decimal place or 4 decimal place. For me, I keep it 4 decimal place, because your table will give you 4 decimal place. But again, we haven't used the table, so most of them is your calculator. So question here, ladies and gentlemen, question with how to look at this problem and how to type in your calculator. We spent some time with the calculator, so I did not show you all. But if you need to see where to locate the feature normal CDF and how to type it in your calculator, let me know, because no, we've been doing this for 3 days, I guess. So question with A. And again, B is the same, right? They ask you for the probability of this item. As long as they don't mention anything about sample, we are deal with the population. Okay, if they mention something about a sample, we deal with a sample. So in this case, we still have our mean as in 182, our standard deviation is still 14. So now they ask us what is the score less than, which is anything to the left of 150 will be less than 150. And again, the number, if you look at the curve, is not really precise, and we don't really need it to be precise, right? I mean, in the middle of this thing is 182. I know the mean is 182. 150 should be somewhere down here further away. But again, we don't really need to be precise in terms of that. We just need to have an idea of which area we're looking for. Is it to the left of the number or to the right of the number or in between? It just gives us an idea of what kind of our endpoint we're using. So because we're looking for the item on the left, we know that some small number will be on the left, which is we use a negative a million or 10 million. And the upper limit will be 150. My mean is 182. My standard deviation is 14. I using the normal CDF, and I will get 0.0111, which is roughly 1%, right? Based on this data, only 1% of the bowler will score less than 150, right? So again, they in the bowling league, they should have, they should have a good score, right? So based on this thing here, as you can see, this is 6.1. We deal with the population. And when we get to see, when we see there are a sample, now instead of using the whole population data, we have, let's say we go to our local bowling alley, and we just select 100 bowler from whatever the league is, right? Because now we only deal with this 100 local bowler. What is the probability that a sample mean is greater than 195? So because we deal with this sample, this is what we need to do, is we need to adjust our standard deviation, or in a term, we need to find a standard error. And to find a standard error, we need to take a standard deviation, the population standard deviation, divided by a square root of n. And in this case, we have 14 divided by a square root to 100. And again, square root of 100 will give me 10. So 14 divided by 10 will give me 1.4. This is our new standard deviation, or this is the standard deviation that we were using because we are dealing with a sample number of items. Okay, so again, because they give us a sample, and this is what you need to do. Anything that we do with a sample, we need to adjust the standard deviation. So once we adjust this thing here, now the only thing different is we need to using 1.4 instead of 14, right? So if you look at A and C, we have exactly the same structure. If you look at the bell curve, right, we're looking more than 195. On A, we're still looking more than 125. But again, because we deal with the sample, we have to adjust that. And again, this is what we have is the lower limit 195, the upper limit is some humongous number. And again, the mean is the same, 182, but the standard deviation now we are using 1.4 rather than 14. Okay, and that's what your goal is, ladies and gentlemen. That's what you have to ask yourself. That's what you have to ask yourself in terms that because they give us the sample, we have to adjust the standard deviation. Okay, so again, one thing I want to point out that if you type in your calculator, you will see that 8.1606 e to the negative 1. Again, e to the negative 21 is basically tell you that you have to take this decimal and move it 21 spaces to the left because it's negative. Imagine that your number line, right? Your real number line. If you go to the right, it's positive. If you go to the left, it's negative. Meaning again, the decimal is right here. You have to move 21 spaces. So 8.16 is not the probability. Okay, it's 8.16 e to the negative 21, meaning it's basically is very humongously small. Okay, based on this sample, based on this 100 sample, is very, very, very rare that the sample mean will be bigger than 195. Okay. So again, this is the idea, or with this problem, I want to show you that because we deal with the sample mean, we need to adjust that. And again, once we find, or once we see that they based on 100 Bowler, which is the sample mean, they ask us the sample mean between 175 and 195, which 85, which is the middle item right here. And again, the between is easy. Whatever our lower endpoint 175, whatever our upper endpoint 185, the mean is 182, and the standard deviation is 1.4 because we are dealt with the sample mean. So once we identify the sample mean, this is what we have, which is again based on this Bowler, or based on this item here, we have roughly 98.4% of the Bowler will be scored between these two score, 175 and 185. Okay, so again, hopefully you guys see when to adjust your standard deviation, right? When do we adjust the standard deviation, and when we just using the population standard deviation. So if you don't see it, let's try another one, right? Well, first of all, question with this slide here, question with A, B, C, or D. All right, if you don't have question, let's take a look at this item here. Same thing though. They give us, or I give you guys this item here just to show you guys, or just to kind of mention in terms that when are we using the regular population standard deviation, and when do we have to adjust the sample, or we have to adjust the standard deviation, right? So looking at this item, we still have the same item before, 182 point, and the standard deviation of 14 point. So they ask you a trophy is given to each player whose score is at or above the 97th percentile. What is the minimum score needed for the bowler to receive a trophy? So we just want to give the top 3%, right? The top 3% is the same as the 90. Reminder, what is the word percentile? The percentile meaning is the percentage to the left. Okay, that's what the word percentile means, is basically from the left, you add up to 97% or 97th percentile. So we want to give at 97, or in the center of this thing here, 97, 98, or anything above this item will get the trophy. So because they give us the percentile, or they give us the percentage, reminder, we need to do the inverse norm, right? Those are your two items in chapter 6. Is either we doing the normal Cdf, which we find the area or the percentage or the proportional or the probability underneath the curve, right? The area underneath the curve, or you find the actual score. And in this case, they ask us, we need to know what is the bowler score. And to do that, we need to do the inverse norm. And reminder, for my or some of you guys calculator, we can only give the calculator the percentage to the left. And because they say 97 percentile, that is the percentage to the left. So all we need to do is put in the percentage to the left, and the mean and the standard deviation is the same, which is 0.97. The mean is 182 and the standard deviation is 14. We know, or in this case, the bowler have to score. And one thing about this item, you say, wait a minute, Mr. Tran, 280, 208.3, the 3 is less than 5. Why do I route up? Because the score is discrete. If you go bowling, you know that the pin, we cannot get half of the pin, right? It's either fall down or stay up, right? It's either the whole pin or nothing. So because it's discrete, we always have to go up 1 to make sure that we include everyone. or in this case, we want to make sure that if you score 208, you are not at the 97 percentile, right? So we need to make sure that 209 will be the top, or 209 will be at that item. Okay, so again, because of the discrete data, reminder, the discrete data is you either count 1, 2, 3, 4, 5, right? The number of pin, or the number of simply, or the number of books you have. You cannot have half of a book, right? Or you cannot have a person. So in this case, because it's the discrete data, that's why we go up to the next whole number. I think your homework, they tell you how they want it to be. They tell you go to the next whole number or something like that. But go to E. The difference between E is because we deal with that 100 bowler. We deal with this local 100 bowler. And because we deal with this 100 bowler, we deal with the mean or sample mean. And because we deal with sample mean, reminder, because we deal with sample mean, we have to adjust our standard deviation. So in this case, again, the 49 percentile is the same. As long as they tell you percentile, that is the percentage to the left. And again, the percentage to the left tell me that is 49%. Now I just need to put in my inverse norm. Inverse norm 0.49. The mean is 182. The standard deviation in this case is 1.4. And in this case, based on this information, based on this sample, the sample have to be score 180. No, kind of not 182. You say, well, 182 is 50% at the average, but again, just because of the discrete, we round up to the next whole pin. So if you have a score of 182, you are at the 50%, you at the average, right? Meaning you are bigger, you are higher, you are greater than 49 other people, for say. Okay, so again, in this sense, the goal or the idea or the illustration that I want to point out is, just because this kind of like the keyword that you need to looking for, when you read a problem, if they ask you for percentile or proportional or probability, you ask yourself, well, do they ask me to deal with a sample mean? If they do, I need to adjust the standard deviation to find the standard error, which is take the standard deviation, divide by a square root of n. If they don't, then I will deal with the population standard deviation, and whatever the population standard deviation they give me, that's what I will be using. Okay, and that's the biggest thing moving forward. You will see in chapter 7, in chapter 8, this is the biggest thing that we will see, or the biggest thing that you will have to identify is, are we working with the population, or are we work with the sample? Remember, our class is statistic, right? Statistic, and if you remember in chapter 1, statistic is the number that deal with the sample. So we will expect that we would do a lot with sample, right? So again, parameter is the word that describes the population. We are not in the parameter class, right? We are in statistic class, and as you will see, we deal with a lot of sample item. So in this case, question on E versus D on this slide here. Well, let's try one more. Similarly, different information, but different information, but identically the same. And like I say, I don't believe your test will have something like this. The only reason I give you this set is to tell you, or to show you, when are you adjusting the standard deviation versus when you use the population standard deviation. Okay, I think your homework and your quiz, each of the question have its own, is not in this item, but I just want to show you, if we have the information, how can you decipher the the wording, right? So looking at this thing here, the running time of the video on YouTube on any given week is normally distributed. And again, they just tell you normally distributed, meaning is a bell-shaped curve with the mean of 390 seconds and the standard deviation of 148 seconds. If a single video is randomly selected, what is the probability that the running time of the video exceeds 6 minutes? Again, this is the other thing that you have to pay attention is your data they give you in second, and now they ask you or they give you a minute. Make sure that you need to convert the minute to second, right? Each minute is 30 seconds, so 6 times 60 will give you 360 seconds. So make sure that your data is aligned with each other. If they give you, I don't think they give you in feet and ask you something in inch, but they could, right? You need to know how to convert your data so that they align. If you're using the 6 minute, you will see that will be roughly probably 99 no 0.9999999 something percent. But because the 6 minute and the 360 second is very different in term number. But if you act like it's the same, then they will tell you it's wrong. But anyway, let's take a look at this thing here. If you see this question on your test, on your homework, on your quiz, are we using the regular standard deviation in terms of the population standard deviation, or are we have to adjust? And hopefully you see that we are using the regular one. The video is in the module. Remember, the recording is all in the module. You do not access the video in the Zoom. I post all the video in the module. So if you click on the module, you will see there is a module of chapter 5 and chapter 6. And if you click on that, all of the video is in there. You don't need the password for those video in the module. Okay. So looking at this thing here, if you look at this item, because they don't give us anything related to a sample, if they don't give us anything related to the sample, we know that we're just using the regular, the population mean and the population standard deviation. So in this case, this is what we have is we want to know, again, remember what does it mean? Exceeds meaning more than. And if it's more than, in this case, we can see that if it's more than 360, meaning anything to the right of 360 in this case. So since that we're looking for anything to the right, we know that our smaller endpoint is 360 and our upper endpoint will be some humongous number. And when is and the mean and the standard deviation is the same. So once you have this thing here, you will have roughly 58% or 0.5803 as in the probability of the video is longer than 6 minutes, right? So again, if you saw the video that I post is in hours, so again is based on this thing here. This is not one of the lecture video. But again, now if you look at B, suppose that a sample, and again that should trigger something. Suppose the sample 40 video, and because we are dealing with a sample, right? If you look at this thing here, A and B are exactly the same, right? They ask you what is the probability that the mean running time of the sample exceeds 6 minutes. Again, the only thing different between A versus B is that keyword. And if you see that keyword sample, you should know that this is what we need to do. We need to take the standard deviation and divide by a square root n. And if you do that, this is your new standard deviation, which is 23.40 And because it's a decimal, like I mentioned on previous time, use at least 6 decimal place. And again, like this is what we have in the center of your item. And again, like the main difference, if you look at this thing here, this is just the main difference between the two, right? One of them, because we deal with the population, we're using the same population standard deviation, but because we deal with the sample, we have to make this adjustment, and the adjustment, we call this a standard error, and that's the only thing different is the sample versus population. Okay. So, and again, like I mentioned, the only reason I give this item on the same slide is to show you how you can different between the two, between when do we use the population standard deviation versus when are we using the sample standard deviation or a standard error. So question with A or B here, ladies and gentlemen. And would it be unusual if a sample mean, again, sample mean, right? Because they tell us the sample mean, we are deal with a standard error, which is we deal with the sample standard deviation in B. So would it be unusual if the sample mean less than 300 seconds? So we know that we're looking for less than 300 seconds, meaning anything below 300, right? In terms of 300 seconds. So we know that this is what we're looking for. And if you do this thing here, you put in the negative a million or negative 10 million, then 300, and again the mean is 390, and the standard deviation is the adjusted the standard error, which is 23.400. And if you look at this thing here, please, ladies and gentlemen, do not jump the gun. Do not say, oh, 6.05, that's bigger than the cutoff 0.00.05. Remember, the negative e to the negative 5 basically tell you take this decimal place, move it 5 space to the left, right? The decimal place here, I move 1, 2, 3, 4, 5. So this is the item which is 0.00006, meaning this thing here is way smaller than the cutoff of 0.05. And because it's more than 0.05, we will say that is unusual. Okay, this is very unusual. Based on this probability, is very unusual for a video that is less than 300 second or less than 5 minutes. Okay, so again, based on this thing here, based on this information we have, and again, do not jump the gun and say 6.05, that is bigger than 0.05, because of the e to the negative 5 tell you to move it 5 places. Okay, and again, go back to D, because they tell us, I purposely tell you that we are deal with the population here, and if we deal with the population, we have to use the population standard deviation, or in this case, we do the inverse norm, and we do the 0.87, which is the percentage to the left. 390 is your mean, and 148 is your standard deviation. So looking at this thing here, in order for the video to be considered 87 percentile, that video have to be 556 seconds, right? So 57 seconds, or if you look at that. But looking at this thing here, question with this slide here, ladies and gentlemen, question with this item. Now let's take a look at this thing here, and if you look at this thing, make sure, or if you look at this item here, hopefully you see that this problem is different from the previous. How different? Because they ask you to approximate, right? They ask you to approximate, and yes, that's stutter, like that small word tell you differently, right? Last time I told you that if you work with a sample mean, we have to adjust the standard deviation to become a standard error. Now, this thing here, you say, well, Mr. Tran, they have a sample. They give me the sample of there. They give me this sample of 120. But how do I know that I do not take the standard deviation and divide by a square root of 120? Well, looking at this item, do they give you the mean or do they give you the standard deviation like the previous one, right? Do they give you the mean and the standard deviation like the previous item that they have, or this item here? If you look at this item, they tell you the mean, they tell you the standard deviation. If you look at this next problem, they tell you according to the net market share, 83% of the internet searcher are search in a region using Google search engine. A sample of 120 search is 30. So looking at this thing here, they don't give you the mean, they don't give you the standard deviation, and they ask you approximate. Well, that's something new. Approximate the probability. So again, remember, in terms of approximation, or to do the approximation or approximate this item, we are in 6.4, and this is where we have to do the whole 9 yards, right? What are the whole 9 yards? Because we need to find the mean, we need to find the standard deviation, and also we need to adjust the endpoint. This is what we covered last Tuesday before our storm. So looking at this item, how do I find a mean? Reminder, to find a mean, this is what you need to do, is you need to take the n times the p. The n times the p, that is your mean. And in this case, the n is 120, which is the total number of items we study. And the p is the probability that each one of them, the probability of one of them will use the search engine, or in this case, the percentage they give you is the p, the probability of success. So the n times the p, which 120 times the p will be 0.83, so will give me 99.6. And then to find the standard deviation, I need to take a square root of the n times the p times the 1 minus p. So the n times the p times 1 minus p, this is what I have. And reminder, if you want to type in square root of 120 times 0.83 times 0.17, that's fine. If you don't, you have to use at least 6 decimal places, 4.114851. Okay, don't use 4.1, that's it, because if you use that, you estimate your answer will be a little bit bigger or smaller than your item. So once we have this thing here, that is the first thing we need to do. We need to adjust this, or not adjust, but we need to find a mean, and we need to find a standard deviation to approximate this item. So now they ask you approximate the probability that more than or equal to 94 of the searcher using Google. So how do I do this thing here? So reminder, first of all, this is what we need to do. We need to ask ourselves, we want the probability of X bigger than or equal to 94, because it's more than or equal to 94. And if we do this thing here, this is what you need to ask yourself is, do we include our endpoint? So hopefully you guys say that, yes, we include the endpoint. We're looking for the item to the right. We're looking for the item to the right of 94, right? Bigger than 94, bigger than or equal to 94. So we're looking for the error to the right of 94, but now do we include the 94? And hopefully you say, yes, we include the 94. And because we included 94, we need to adjust this endpoint by moving this endpoint slightly to the left, right? To include this endpoint, to include the item on your right, you have to move to the left. And if you move to the left, you need to subtract 0.5 or minus 0.5. So in this case, your new endpoint will be 93.5. Okay, so we adjust this item. We're using our new endpoint 93.5. And again, this is what we have. We put it in. We use our lower limit 93.5, my upper limit some humongous number, my mean 99.6, and my standard deviation 4.11485115. And again, this is the probability based on this item. We approximate them. This is the approximation of 0.9308 of the people using Google, of the 120 that we have using Google to search whatever they need to search. Okay. And again, let's do one more, and then I will pause and ask you guys if you have question. Approximate the probability of fewer than 90 of them using Google. And again, fewer than 90, this is what we have, is probability of X fewer smaller than 90. So we're looking for the item is less than 90. As you can see, there's no equal sign. We do not include the endpoint because 90 is not fewer than 90. So we do not include the endpoint. So fewer than 90, this is what we're looking for. We're looking for the area to the left of 90. We're looking for the area to the left of 90. No, the test is only chapter 5 and 6. Again, to the left of 90, which is this is the item. Same idea go. We need to adjust this endpoint. How do we adjust this endpoint? Well, do we include the 90? As you can see, we do not include the 90. And if we do not include the 90 and we're looking for the area to the left, and this is, like I mentioned to you guys, a little bit confusing in the way of why over here we move it to the left and over here we move it to the left too, is because this item is, we're looking for the area to the left and we want to exclude the 90. So we still have to move slightly to the left so that we exclude the 90, because again, this is the area we're looking for, right? Over here, because the area we're looking for to the right and we want to include the 94, so we move it to the left. This one here, because we want to find the area to the left and we want to exclude the 90, we want it to throw this thing away, so we have to move it to the left too, because the area we're looking for is to the left. If we move it to the right, we include the 90. Okay, so that's why sketching this item is very, you know, is very unique or needed, so that you can have an idea of which area we're looking for. So in this case, again, we're looking for the area to the left. The smaller endpoint will be some negative, some humongous number. The upper endpoint will be my adjust endpoint, which is 89.5. We do not include the 90. And the mean and the standard deviation is the item we find earlier. And if we do that, you will see that 0.0071 will be fewer than 90 people from this item. Okay, so first of all, question here, ladies and gentlemen, question with how to find the mean, how to find the standard deviation in this case, and how do I find, or using the adjustment of the endpoint to find the approximation. Again, whenever you have, or whenever they ask you to approximate, you have to adjust your endpoint. There's no way out of it. Question?
Why did you use endpoint in number A?
For A?
Yeah, like you said, we have to use it the endpoint for A because of the A is equal or larger than 94. But I don't know, where did you use I'm sorry, the endpoint for the A.
So looking at for A, this is my A question, because my endpoint is 93.5, and
Right.
I'm looking for the area to the right. That will be my lower limit. my lower limit will be 93.5 and my upper limit will be some humongous number. So
Okay.
that's where my endpoint is right here. 93.5 will be my lower endpoint, and my upper endpoint will be some humongous number, which is 10 million, and my mean and my standard deviation.
Oh, okay. I see. Oh, we don't use the endpoint. Okay. Okay, I got it.
Okay,
Also, 89.5 would be
the upper limit.
upper limit. Yeah. Okay.
Yeah, so because right here, 89.5 will be somewhere here. So the lower limit will be some humongous number, say negative humongous number, and the upper limit will be 89.5.
Okay, got it. Thank you.
So we're still using the same normal CDF like before. It's just that now we have to adjust the new endpoint. All right. And if you're looking at this thing here between 100 and 110, and because they say inclusive, meaning we need to include the 100 and the 110. And if we include them, if you look at this item here, if we include them, and again, between is easy, right? Between is basically, again, this is what we're looking for. We're looking for the error in between these two. And if we're looking for the error in between these two here, this is what we have. And because they ask us to include the 100 and the 110, everybody see that I need to slightly move to the left and slightly move to the right of the two endpoint. And in terms of this thing here, this is my endpoint, which is 100 minus 0.5 will be 99.5, and 110 plus 0.5 will be 110.5. Again, the approximation or approximate, you will always have to adjust, and your endpoint will always be 0.5 in terms of that. So my lower limit will be 99.5. My upper limit will be 110.5 because I'm looking for the area in between. The mean is the same, and the standard deviation is the same as before. So this is what I have. And again, the only thing different in terms of this approximate is you need to adjust the endpoint. On top of that, you need to find the mean and the standard deviation, because in chapter 6, without the mean and without the standard deviation, we cannot find the area, or we cannot find the other item inverse norm. So we need to find the area, the mean and the standard deviation if they ask you to approximate them. Again, if we deal with the sample, we need to find the standard error, which is the standard deviation divided by square root of n. If we deal with the population, we don't need to do anything. Whatever information they give us, that is what we will be using. Okay. All right. Let's take a look at this item here. And again, I don't think I covered this. I mean, I think I covered this, but I'm not in detail. If this were to be on your test, and again, this problem and this problem is identical. It's just that this one here, they give you in wording. This one here, they give you in symbolic, right? So they tell you something, right? They tell you we need to use the normal to approximate this item here. So they give us the binomial distribution, the n and the p, and they say use the normal to approximate the probability of x greater than 83, 75, between 75 and 95 inclusive, less than 96, more than or equal to 85. 89, right? So again, instead of tell you, instead of give you the information, they give you this symbolic. And if you see that we need to use the approximation, we need to use approximation, meaning again, we need to adjust our endpoint. But before we adjust our endpoint, in order for us to use the normal, we need to find the mean and we need to find the standard deviation. So again, they give you the same information as before. It's just that they don't give you the story behind the information, right? They can say that the chance of make a profit in the stock market is 0.38 or 38% of making profit, right? And then 240 stockbroker is selected. What is the probability of more than 83% 83 of them make profit. No, they can give you whatever story they want, but again, this thing here, there's no story behind the data. Hopefully you can see that they give you this data, and this is what we need to do, is to find the approximation, or to use the normal approximation. We need to have the mean, we need to have the standard deviation. And once we have this thing here, again, we need to adjust our endpoint. So look at this item here. We know that we need to find the area to the right of 83, but do we include the 83? And hopefully you guys say, no, we do not include the 83 because there's no equal sign. Last time there's an equal sign, we include them. All right, like D, we include the 89. This one here, there's no equal sign, we do not include the 83. So if we don't include the 83, everybody see that I need to move slightly to the right, because I don't want to include the 83. I want to find the area to the right. So I need to throw away the 83, and to throw away, I need to move slightly to the right. I need to add 0.5. And if I add 0.5, my new endpoint will be 83.5, my humongous number, because it's to the right. My mean will be 91.2, and my standard deviation is 7.519574456. And again, everything else is the same, right? Like I mentioned, the only reason I want to show you guys this is if they give you symbolic rather than tell you in wording, you know what to do. Okay. And again, for B, we're looking for this area between 95 and 75. And again, we include this item. Why do we include this item? Because there's an equal sign underneath your inequality. And if I include this thing here, similar to before, I need to slightly move to the left a little bit and slightly move to the right a little bit. And my new endpoint would be 74.5 and 95.5. Those are my new endpoint. I need to extend this, make this area a little bit bigger. And to make it bigger, I need to go both sides. I need to go to the left and go to the right. If I want to make this thing smaller, then I need from the left, I need to go to the right, and from the right, I need to go to the left. Okay. If I need to make it smaller. But again, how or when do we make it smaller, or when do I make it bigger? That's the question that you need to ask yourself, is do you include the endpoint or do you exclude the endpoint? And again, once you have this thing here, like I say, the feature in your calculator can do the rest. The problem for you guys, the challenge for you guys, is how do you tell the calculator to do it? Okay. And again, let's take a look at C. We're looking for the area to the left of 96. And now let me ask you, do we include the 96 or exclude the 96? Hopefully you guys say we exclude them. And if we exclude them, everybody see that we need to move it over here to exclude this item here. And to move it to the left, I need to subtract 0.5. And if I subtract 0.5, everybody see that my new endpoint will be 95.5. So this is what we have, or this is what we need to do once we have this item here. And again, lastly, we have greater than or equal to 89. Greater than or equal to 89 is on this item. And because I need to include this item here, we need to subtract. We need to subtract 0.5, and this is my new endpoint, 88.5 as my lower limit. So again, like I mentioned, this thing here is just the same as before. It's just that instead of type it out, they give you the symbolic, and hopefully you can see the symbolic is how do you take the symbolic and transfer them to the shade of the region. Question here in terms of A, B, or C here, ladies and gentlemen. All right. Let me skip one page. I will go back if I have time. Let me go focus on the let's take a look at this item here. Because it's a while since we see this thing here. we've been doing in terms of chapter 6, right? All 6.1, 6.2, 6.3, 4. This thing here, if you look at this item, if you look at how do you determine, if you look at the item, how do you determine if it's chapter 5 or chapter 6? They say at the large clothing store, 20% of all purchased items are returned. A random sample of 12 purchase is selected. Find the probability that exactly 3 of the purchased item will return. More than 2, fewer than 2, find the mean, find the standard deviation. So looking at this item here, remember in chapter 6, they will tell you, or they give you the mean, they give you the standard deviation, and they actually find the probability between more than or something like that. And in 6.4, they tell you approximate something. Now, if you remember in chapter 5.2, this is what we have, is we have a binomial distribution. And what is the binomial distribution here? Is either you return the item or you do not return the item. Those are the two outcomes, right? And again, the probability or the chances of returning an item is 20%, which is 0.2. And this is what they ask you to do, is exactly 3. So how do we do this thing here? Well, remember, to do this thing, to do this item, this is what we have, is we know that we have an N and we know that we have the P. The N is how many people are in this survey or in this study or in this item. The sample or the total number of items, we have 12. And the P is 0.2. And if you remember, this is what our X is. Our X is 3, right? So looking at this item, look at this item right here. Remember, how do we use or what are we dealing with in terms of chapter 5.2? If you hit second var, which is your normal CDF, and if you go down, I told you in chapter 5, this is the two items we have in terms of binomial PDF versus binomial CDF. So what is the difference between binomial PDF versus binomial CDF? If they ask you for the exact point, that is when we're using the binomial PDF at one particular point. So if it's at one particular point, this is what we have in the sense of PDF. And reminder that this is what we need to do, is we need to put in our X, we need to put in our N, we need to put in our P. So all you do is, once you have this, all you do is you press in 3, 12 is your N, the P, which is 0.20. And again, you the only reason why I sorry, let's see, is it N? Give me 1 second. Is the NPX, not the XNP, sorry. This is the NPX, so you need to put in the total first, and then you need to put in the P and the X. So if you plug this thing in, your calculator, and again, TI-83, you have to manually type it in. If you have TI-84, it's easy. TI-84, you have the prompt for you. So again, we're using the PDF here, and we're using the 12, 0.2, 3. And again, if you type this thing in, you can see that the probability of exactly 3 of them return is 0.2362. So this is the item we have. This is the item we have in terms of the binomial PDF versus binomial CDF. And again, the only time we're using PDF is exactly at something. If it's more than or less than, we using the CDF. And reminder, this item here, for me, for my calculator, the binomial PDF or CDF to be exact, can only calculate the item to the left. Okay, just like your approximation, just like the previous 6.4 example, you have to ask yourself, do we include the endpoint or do we exclude the endpoint? Okay, so when they ask you the probability of more than 2 purchase will return, what does it mean more than 2 purchase? Well, more than 2 purchase meaning my X is at 2, but is 2 more than 2, right? 2 is not more than 2. So again, this is what we need to do, is we need to do the binomial CDF, 12, comma 0.2, comma 2, meaning I want to tell my calculator, find me the probability of the 0, the 1, and the 2. Because I'm looking for the item more than, if I did not write this thing down, but if you look at your number line, if you remember your number line back then, right? Because 2 is not more than 2, so all I need to do is tell my calculator, calculate to me the 0, the 1, and the 2, meaning the accumulation of the 0, 1, and 2, give me that answer. But then we have to make a small adjustment, because this item, your calculator can only give you the answer to the left. When you type this thing in your calculator, binomial CDF, the 12, comma 0.2, comma 2, your calculator calculates the 0, the 1, and the 2, and the 0, 1, and 2 is not more than 2. So that's what we need to do, is we need to take 1, which is the maximum probability, minus the answer. And if we take 1 minus the answer, this is what we have, in the sense that 0.4417 will be my item that I have, or that is the item, the probability to the right, the probability of more than something. Okay, fewer than 2, reminder, same idea go, fewer than 2, the 2 is not fewer than 2. And because it's not fewer than 2 is only the 0 and the 1. So we do not include this item here, which in this case, your binomial CDF will be, you tell your calculator to calculate the 0 and calculate the 1, which is the CDF. If not, you can do the individual PDF of the 0, PDF of the 1, and add them together. But again, the CDF tell the calculator to calculate the probability of the 0 item return or the 1 item return. Why do I don't do the 2 item return? Because 2 is not fewer than 2. Okay, so that's why we need to ask ourselves, first of all, to use the PDF is when you find the exact at one particular point. To use the CDF is when you need to do the accumulation of point. And when you do the accumulation of point, most of the time they will tell you more than something, or less than something, or fewer than something, or greater than something, right? Those are the accumulation of point. So to reminder, if you remember this or bring back memory, more than whatever the answer on your calculator, you have to subtract that from 1, because your calculator can only calculate the item to the left. Fewer than whatever the answer on your calculator is, that is the answer we have, or that's the answer they ask you. Okay, so the other thing is you need to ask yourself, what is the endpoint? Do I include the 2, or do I include the number, or I exclude the number? And because it's and you say, wait a minute, Mr. Tran, why don't we just subtract 0.5 or something like that? Reminder, the binomial distribution in chapter 5 is a discrete data. And the discrete data, we have to go up 1 or down 1. We cannot take half of it. Okay. We use the normal distribution. That's when we take half. D and E is what is the same as we have before. To find the mean, we take the n times the p. To find the standard deviation, we take a square root of the n times the p times the 1 minus p. So again, to find the mean and standard deviation is the same as we've been doing when you use 6.4. Okay, so looking at this thing here, this is what we have in terms of chapter 5.2. And let me cover the other item that you have that I did not cover, which is this item here. The other item in chapter 5 is we have a probability distribution. And reminder, the probability distribution is basically tell you that you have some probability and you distribute it evenly. Well, not evenly, but you separate them out in terms that the total probability cannot be bigger than 1, and the probability does not have a negative number, right? So in this case, they give you this item here, and this item, hopefully you remember that is very easy to do. There is no calculation involved except E. But looking at this item, they give you the number pet, and you have 0 pet, 1 pet, 2 pet, 3 pet, 4 pet, right? So they ask you to find the probability of a random family have 2 or 1 pet. And again, 2 or 1, which is in this case, we know that this is a mutually exclusive. You either have 1 pet or 2 pet. And again, you just add them together, the 1 and the 2, which is 0.3 and 0.1. So again, the probability of a family have either 1 pet or 2 pet will be 40% or 0.4, right? More than 2, again, same idea. More than 2, we do not include the 2, which is the 3 and the 4 only, which in this case 0.075 plus 0.025, that will give you 0.1 or roughly or 10%. And no more, again, I don't, well, in case I give this thing here just in case. What does it mean? No more than 3. Again, you know, math is hard already, and then they put this word in try to confuse you. No more than 3. Do you agree that no more than 3 basically less than 3, right? 3 is not more than 3. Well, 3 or less, right? No more than 3, meaning again, basically we looking for something that 3 or less, because 3 is not more than 3. So 3 is not more than 3, 2 is not more than 3, 1 is not more than 3, and 0 definitely not more than 3. So basically, again, basically they tell you is find the probability of 3 or less, right? 3 or less, or it cannot be fewer than 3. Fewer than 3 would be the 2, right? It has to be no, at most 3 or less. So in this case, this is what we do. We just add the 3, the 2, the 1, the probability of those items. And at least one reminder, the word at least is include the 1. At least 1 meaning, again, the 1, the 2, the 3, and the 4. So if you add them together, you take the probability and you add them together. This is the other thing, that the hardest thing that that you guys have problem with is how do you, given this item, how do you find a mean and how do you find a standard deviation? Reminder, to find a mean and standard deviation, this is what you need to do is you need to use your 1-var stat. But before you do the 1-var stat, reminder that you need to hit stat and edit your item, right? So again, this is what you need to do is if you at the home screen, if you're at the home screen, you need to hit stat and then edit, which is that your edit item. And then all you need to do is type in your L1, your your number of pet, in this case is your data is L1, which my data is 0, 1, 2, 3, and 4. Those are my data. And then your L2 will be your probability, which is 0.5, 0.3, 0.1, 0.075, 0.025. So reminder that this is what you need to do is you need to type in L1 as your X data, your value, your L2 is your probability, and then you hit stat again, and you go to calculate. So again, this is the feature we use in 1-volt stat. And if you have my calculator, the TI-83, you have to type in L1, which is second number 1, comma, second number 2. For L2, you need to type in L1, comma, L2. Tell your calculator that we have the L1 and we have the L2, meaning my data in L1, L2. Go ahead and do that calculation for me. If you have the TI-84, your frequency is your L1, your frequency list is your L2. And again, this is the two items we have. The mean is 0.825. The standard deviation is 1.046. So again, this is what we looking for, the mean and the standard deviation. We did this before. And I show you that we can do it by hand, which is a little bit tedious to do it by hand. And that's what you do is, if you don't do it by hand, your calculator can help you in terms of your L1 and L2, which is you hit stat, enter in your L1, L2. Question with this item here, ladies and gentlemen. Well, if you don't have question, I don't think 6.5, I don't believe 6.5 is on your test. But 6.5 is basically tell you two things. It basically tell you two things is if you have an outlier, this is we kind of can speed through 6.5. Basically, this is what they tell you in 6.5, ladies and gentlemen, is if your data have an outlier, then we cannot use it. It's basically tell you that if you look at the information, can you guesstimate that we can use the normal distribution to do it? If there's an outlier, we cannot do it. If there's some skew to the left or skew to the right, we cannot do it. If they have more than one mole, we cannot do it. And again, that's all they tell you is, if you look at this data, if they give you this data, can we use the normal approximation to do this item here? Again, if you graph this, if you do the dot plot, you can see that your data kind of together, like there's no outlier, like there's no one point somewhere further away, and there's no mole, right? In this thing here, they kind of scatter out pretty good, and there's no one or two mole in terms of this item. So this is all they tell you is, can we do it, right? If we look at whatever data they give us, can we use the normal distribution to force our way and make it a bell-shaped curve? If you look at something like this, if there's an outlier, meaning again, I feel most of your data is somewhere close over here, and all of a sudden you have one data all the way on the right. So there's look like there's an outlier, and if there's an outlier, we cannot do it. That's what 6.5 tell you is, can we force, if we look at some data, can we force ourselves to use the normal distribution to do it? And that's what the assessment of the normal item is. If you look at this two graph A, we cannot use this normal approximation because there's an outlier, there's an X here, right? So because there's an outlier that does not fit the description, as long as there's an outlier, we cannot use it. As long as you have some skewness, meaning again, you either have like a bunch of data to one item, one side, and not, it's not kind of scatter out, then we cannot use it. Okay. And again, over here, we can see, you see that this thing here is we don't have an outlier, so that's good. And this thing here, even though they tell you, even though the mean and the median is not where at the center, but we can force our way and kind of use it. It's not the best. It's not the best because it's just estimate this item here. But basically, that's what 6.5 tell you to do is, can you guesstimate, or can you, using the item we have, can you use the item we have to estimate our um, our normal distribution. Okay, so again, I don't believe it's in your task. You know, it's, you have a homework, but the homework is pretty. You can, I think you can do those homework without my point out. But